Hello everyone. We are going to demonstrate the design of a protoboard spacer. This is the drawing of the file. The first thing when you get a drawing is try to understand it, look into the 3D shape, and then start to understand the dimensions and how you want to go about it. This looks like we have a sketch and we have to derive and understand the dimension from this sketch and from this one, as well as from some of the lateral dimensions in here. And then finally, this sketch will be extruded. We will create a pad. So let's start taking a look into this design and how we would do it within CATIA. I'm going to move it so that you can see my CATIA. So first of all, as a reminder, we click Start, Mechanical Design, and Part Design. Make sure you do the right naming. So capital P R T, which stands for part, then your initials, your first name and your last name. Don't use your initials, the three names. And then you name the part, and this one I'm gonna call it Proto Board and V01. And I'm going to maximize the view of the design tree so that you can easily access it. So this looks like it's going to be one sketch, and I am going to do this on the YZ or on the XZ plane. It doesn't matter. I'm gonna select the YZ plane and click on sketch, and I'm going to demonstrate how I would go about it. So let me bring again the design a little bit. Looking into the design, I'm going to start with this point. What I'm going to do is I'm going to create something that looks like this shape with approximate dimensions. Now make sure that you have the units set right. The units that I have in here are in millimeters, so make sure that the units you have, they are set right. Let's go ahead and minimize this and create something that looks like this profile. Of course, all the updates wants to show now. So this is a very important tool that I use. Let me show you this. This is in the profile section. The first one you have in the previous ones, we've done circles, we've done ellipses and so on. This one, the profile, is my absolute favorite. And this is the methodology that you should be doing for design. So click on the profile and then start following how the shape approximately looks like with dimension. So I have a certain first dimension that is approximately give or take 140, 130. Then I have a circle, and you can see in here, you can come and click on tangent arc and on a 3-point arc. This is a tangent arc, so I'm going to click a tangent arc and select it. So there is a dimension of the arc set at radius of 60. I am going to be pressing the tab on the keyboard. Look at what is changing under sketch tools. So look at in here within sketch tools. I'm going to be clicking here on the tab. You see in here the values, and then I can come in here and I can actually write 60 if I wanted to, and then move on. So basically you can actually influence the dimension that you want. Now we're gonna go up. I'm gonna move my part a little bit here and zoom back a little bit in. We are going to go up approximately 95. So once again, you can press tab, go to length, and literally put 95. And you want it at a 90-degree angle. So this is, and we can delete some of the dimensions later. Then I am going to go down with, so this is very important. If let's say you don't want it to create constraints anymore, you see in here these elements, you can say, hey, I don't want you to even propose for me constraints, like try to force me to have something. I want to create something that's approximately 50, and you can look at the angles. So this is, you can see there 53. Then you want to move a bit vertical. And the dimensions are approximately 140. And then you go back. So let's say you don't want to select this point. So if, as you can see, it is forcing you to go on the grid. You can come and deselect the grid in here, and this will give you the freedom a little bit more. Then you come down some kind of linear, then another arc, all the way to this point, and then you close it down. So you've created I can select something and delete it. You've created something that looks almost like the sketch it's supposed to do. So you can actually get out from the sketch if you want to see it how it looks like in 3D. You can double click and enter the sketch and so on. So once again, I'm going to zoom in, and actually I did zoom in a little bit too much. I'm going to pan out. So what we're talking about in here is the appropriate method to perform a certain design. You created how the shape looks like. Now the next thing, before we worry about the internal shape, we're going to put the different, we are going to put, I'm going to hide the plane so that I can see in here better. And I'm going to hide even my axis in here, just because I want to see everything so clear. So the next thing that you want to do after you created something that looks like the shape is to start putting constraints. So you click in here, and a hint, if you double click, you keep the constraints active, but let's keep it easy for now. We click one time. I'm gonna go ahead and select this one here, and I'm gonna put a dimension. We know this one, based on the sketch, it should be 15. I'm going to go ahead and put 15. Now, let's go ahead. This one is supposed to be vertical, so I'm gonna come here and select to make it vertical. Okay, so this is important because we have deactivated the creation of constraints. It is telling me that, hey, these are temporary. If you want them permanent, you have to activate the constraints creation switches. So in here, let's go ahead and click OK, cancel this for now. In here, you have these two activation switches. This is for geometrical and this is for dimensional. So let's say you want to say something is vertical, something is horizontal, and so on. This is the geometrical. Let's say you want to put dimensions. This is the dimensional constraints. So now I'm going to click on it again and select it, and I'm going to say this is vertical. And I'm going to select here and make it horizontal. Now, what we're doing is we are trying to ensure that our sketch is ISO constrained. What does ISO constraint means? Means that all the relationships are connected, and then you won't have a free floating sketch. So let's go ahead and continue adding. So in here we have the radius of 60. I'll select here, click on the radius, and we keep it at 60. We have a dimension going from, for this element of 95. We're going to select here the dimension, come and put it equal to 95. We have an angle of 60, so we're going to click here. We'll select on this one and then on this one, and then it's going to open up. So we can double click and put 60 for 60 degrees. The dimension of this one is actually 50, so we can click on this one, select and put it equal to 50. As you can see, the shape starts taking up a little bit, but it looks like we are missing dimensions because we're still not in green. So first of all, I am going to, let me bring back the PDF here. So I am going to copy first of all of these dimensions with the exception of these ones inside, and see the dimensions that we need from here. This 122, where is that? So if we're looking at here, what is this value? This is the bottom view, so we're looking at the bottom. So you're looking from the bottom. So we're gonna put the bottom view. So most probably this dimension 123.3 is this one in here. And then we have some other dimensions, 130, 155. This is the left view. So we are looking at the part from this side. So you can see in here this little bridge in here. And so this area in here, the one that's sloping up, that's this one. This bridge, this one, and this one, and this one. So 1, 2, 3, 4. These are 1, 2, 3, 4. So basically from this point to this point, that's the total from this point to this point. It's a total of 130. And the total from the bottom to this point is 155. So we're going to see how we can profit from these dimensions. So let's continue putting what we have at hand. There is a dimension of 140, we did that. There is an angle of 30 degrees, so I'm gonna click here, select. So this is good. If you have a purple, this means that this constraint doesn't add anything to it. This means that you already have it, and you can see we have the 140, 140, but we were clicking in here so that we click back in here and create the angle that we have, which is equal to 1. Oops, it was supposed to be 30, not 130. Here we go, this is 30. Now another thing you can do is, if you wanted the 30 to appear as we have it, you can select something and move it and drag it around so that you can move the certain elements. So in here we see that there is a tangency missing. So first of all, we're gonna select this and make it vertical. Second of all, we're gonna select this and this one and add a constraint of tangency between them to make sure that they remain tangent at all times. Then we're going to add the dimension of radius 35 and the dimension in here of 59.79. So it is starting to get shape. Let's see, what did we forget from the first stage? We have, oh, tangency in here is missing, so we have to make sure that we have tangency or it will break up. So we have tangency, we have a radius of 60, that's good. We have a first dimension 60, 95, 60, 50. I'm going to move the 50 a little bit so it's a little bit more apparent. 140, 30, 59, we have it, 35, and 15. And this one, well, very clearly this is not vertical, so we have to make sure to make it vertical. All right, so this is a good start of our dimensions. Now we can see some elements are in green, which means they have enough constraints, but very clearly, although we have finished all the constraints in here, we are still lacking some other constraints. So let's go ahead and start adding them. This 123.3, this is the bottom view. So let's go ahead, and this is the bottom view from here. So if you are standing here and looking, what you're gonna see is this dimension and then this dimension in here. So if we take and we look back at it, what we have is 123.3 and then this circular portion. So this circular portion is what is projected in here. So let's add the 123.3 at the dimension in here, the length, and see what this gives to us. So, well, this kind of solved a lot of stuff. 123.3. All right, so this kind of solved a lot of stuff. Um, let's see from the other dimensions if we need anything. So let's take a look. Before I look at the other dimensions, I'm gonna click here and I'm gonna see if it's isoconstrained. The fact that it is telling me that the sketch is isoconstrained, this means that this is good. This means that you cannot add any more constraints. Like if you try to add any constraint anywhere, you're gonna have like just a redundant constraint and it is meaningless. Or let's say I'm gonna go ahead and add a constraint from here to here. It's gonna show it to me in purple. It's gonna say, hey, you don't really need it because what you have defined actually creates the dimensions that we have. So this respects everything at all locations, and this creates my external view of the protoboard spacer. Now let's bring back the PDF. Now what we need to create is this internal section in here. So there is a lot of ways. Some people would not create this. They would create the sketch and then they would create another one and create a pocket. But if we go ahead and create it now, this will help us to actually, when we extrude, when we pad, it will be automatically included. I'm going to go ahead and demonstrate that. So let me exit the sketch and create a pad. And the pad dimension is what we have, 50 millimeters. So we're going to put 50 millimeters and click OK. Now we have our protoboard spacer without this internal hollow element. So double clicking in here and adding a certain shape. So sometimes you have shapes like this. This is like an elongated hole, and or you can recreate it yourself. So you can decide. So if we go ahead and create the element, I'm going to turn off all constraints and everything, just so that I am not limited with anything. And just created it. Now we're going to take a look at the dimensions. So the dimensions that we have between the points, we have, so let's take a look at the dimensions together. This is the design in here. So it's very clear that we have 85 from this one to this one. So this positions us along the X orientation. And this point from this one is 40. So this positions us along the 40. So this will give us the set constraint. Then the dimensions are radiuses of 15 and the lengths of 55. So we are going to add these elements. So first of all, I'm going to click on the dimension from this point to this length. And the value of what we had was 85. Now, because this is so constrained from this side, this element will be pushed closer to it. So this is 85. The second dimension we're going to create is from this one to this point, and this one value is of 40. Now it's going to be pushed down. The next three are going to be the dimension of the element. So we're going to start with the dimension of the elongated hole itself of 55, and finally the dimension of the radius here of 15. Okay, so we have to make sure, so because I have removed everything in here, we did not have any tangency. Let's see if we can create all tangencies at the same time. We can't, so we're gonna do them slowly. Tangency here. So sometimes you have to create these things and make sure that you don't deactivate them. You will get used to this feature. Tangency here, and one tangency from this side, and one final tangency from here. So not having the tangency, this is what forced the creation in a different way. So now we're going to put the dimension here is of 15, and well, another issue, because we have disassembled all of this, is the fact that we did not leave this as vertical. And now that's very easy, 15, and we're done. So we have our complete sketch, our complete design, and we are going to exit the sketch. And because it's object-oriented programming, it automatically created the hole. So if I go there in here and say, you know what, I don't want to show this anymore, so I'm going to select all of them, make them, I'm going to click here, make them construction elements, and I'm going to close it, so as if they don't exist. Well, we do know they exist, so we're going to select them and make sure that they appear. And we're going to exit the sketch. And then that's it. We have finished our Protoboard spacer. Thank you so much for watching this video.